These first couple questions very similar to what we did yesterday. Rotate CD 180 degrees around point D. So trace it. CD around point D, 180 degrees, is just going to move this direction and just extend the line best you can. Well, there's the first part. This would be our new C. It doesn't tell us what to label it. B, around point E, so 180 degrees around point E. Anchor point at point E. Rotate it. Should be parallel to this line. Mark it. Connect the dots. And C, 180 degrees around point M. Just like yesterday, that's going to be in the same spot. Letters just switch sides. Question number 2, isosceles right triangle. What's isosceles mean? Anybody remember that term? What's this mean? Anybody know what isosceles means? Parker? No? Have you never seen that term before? Ian, you've never seen it? Really? Surprising. That means two sides are the same length. So isosceles would mean these two sides are the same length. Obviously a right triangle means it's got a right angle in it. All right, but that's besides the point. Rotate the triangle ABC 90 degrees around point A. Okay, all your triangles should be the same size. And if you're rotating around point A, they all should be connected. Point A. 90 degrees. Then the next one says 180, still connected to A. And then another one, 270. Another 90 degrees. Okay, all of them touching A. Okay, each graph shows two polygons. Describe the transformation to take one to the other. So going from blue to green, how can I get this one to look like this one? I'll just better get it on the screen here. Ian? Yeah? I'd agree with that, but I think it almost has to be slid down first. Yeah, so I would say slide down one. One unit down, slide, and then a reflection across what? Yes. Flips over the Y. So slide one down, flips over the Y. This one's a little tougher. And also, I'm just going to write down point A here. But to me, I would slide A over to where A prime is. And then I would rotate it. So slide point A over to 4, 4. Rotate, what direction did I rotate that? Clockwise? It's like almost 90 degrees. I'm not gonna measure it. So I'll say approximately. That should be just fine. Question number 4. Can you do that with reflections? Yes or no, and why? Othniel, what do you think? Okay, if it was just one reflection, you know, if you're going over a vertical or horizontal line, but I think if you go right at a diagonal here, I think it is possible for those to be the same distance away from the line. So whatever your argument is, if you said no, why do you think that? I'm gonna go with the yes. I think it is possible if you get the right angle line there. I think that's pretty close to being a reflection. But again, whatever you say, just defend it.